Waves. Waves transport energy from one place to another. So, if you had a person holding a slinky, another person holding the other end, then if you send a wave down the slinky, then the energy of this person making the slinky go up and down will get transferred to this person making their hand go up and down. So energy is transferred. So there's two types of wave, there's transverse and longitudinal. Transverse is where each particle on the wave, so here's a particle, there's a particle, only oscillates in the up and down direction. Okay, whereas the motion is up and down, but the actual energy of the wave still gets transferred that way. So in other words, there's 90 degrees between the particle motion and the energy propagation. So examples of this is S wave from earthquakes, like that one there, or electromagnetic waves, and also surface water waves. So this buoy on the surface of the water would actually just oscillate up and down. Under the water is actually something completely different. It's actually circular. So longitudinal, okay, imagine you had a speaker. This will create sound by oscillating back and forth, and the direction of energy travel of the sound is in the same direction as the oscillation. So there's little air particles at the front of the speaker. They will get pushed forward and then they'll get drawn back when the speaker goes backwards. So they're just oscillating back and forth, and what will happen is the actual particles do not move anywhere. You do not get, if you have your speaker and it makes the sound part move, sound travel along, you don't get a big collection of particles at the other end of the room. Okay, the particles stay where they are, they just oscillate around a central point. Words you need to know is compression and refraction. So where there's high pressure is called a compression. Okay, this would be a crest if it was drawn on a graph. Okay, where there's low pressure or a trough is where the particles are further apart. So on a slinky you can send a longitudinal wave down the slinky by just compressing it. And so where the compressions are, there's crests. Where there's refractions, there's troughs. So what's some examples? You've got things like sonar, which is usually just ultrasound. So sound, and also P waves from earthquakes.